Awesome. I think we're live. I think we're live. Can I see any hellos in the chat? If people can chat. No, no one's saying hello. What's going on here? What's going on here? That's all right. Hopefully you guys can all see and hear me. If someone can give me some feedback, that would be awesome. Can you guys see and hear me okay? Hey, Travis. Thank you. Hello, Totaling Arc. Can you guys see and hear me okay? Important question here. Hi, Simon. Okay, Totaling Arc. I'm going to assume that's answering me, so that's good. Thank you. Hey, Shibi News. Welcome, welcome. Hey, Hado. Hey, Gerardo. Hi from San Juan, Puerto Rico. Nice. I like it. All right, you guys can hear me. You guys can see me. You guys are already fingers all warmed up for some coding, maybe. For those of you who are coders. Hey, Grithik. All right. Now I know that one of you is from Puerto Rico, San Juan, Gerardo. Where is everyone else from? Just put it in the chat and let me know where you're all from. And while you're doing that, I recommend, I'm going to put the Git book up here, right, on the banner. I recommend you guys go to that link, open it up, go to the second page, the prerequisites page, if you like, and just start sort of reading it through with one eye, because you may need to do some of the steps. Like if you don't have Avalanche Fuji, you may need to do that. You'll definitely need to install the Foundry tool for the stuff that we're going to be doing today. But I'm going to introduce a few things first. Kevin's from Los Angeles. There we go. We are Totaling Arc from Cali as well. Hado from Australia. What's up, man? I'm from Melbourne myself. I'm in Melbourne right now. I don't know where you are, but it's a cold morning here in Melbourne as we get into our winter. Grithik's in London. Travis is in New York City. Simon's in Kenya. Beautiful. Beautiful. All right. So you guys can see the link. It's in the chat. It's also pasted on the screen as a banner. Definitely open that up. Go to the second page on the prerequisites and setup. Start looking through that. Start doing that now, because while we have a little bit of an introduction, you'll have a little bit of time to get that done, and then we're not going to have a ton of time. So, try and get whatever you can done before we actually start coding in about 10-15 minutes. Yeah. All right, Abdullah is from Nigeria. We've got Timber from North Carolina. Shibi's from Germany, living in Mexico. Sounds like you're living the life. David's from Toronto. Mahesh is from New York City. All right, fantastic, you guys. That's absolutely brilliant. Cool. So why don't we do this? Why don't I start by introducing myself? Let's kick off the workshop now. Let's get started. We've got a special guest for you as well in a little bit. And, so get nicely warmed up or cool down, whatever it is, wherever in the world you are. And, get some popcorn, or get something light to eat, something to drink. I've got my trusty cup of tea here that always keeps me company. And let's get started. So today's workshop is a very special event for us because we're working with Space and Time, as you guys know, one of our key sort of build partners. And so this workshop's about building with Space and Time. It's going to give you a really good, solid overview of what Space and Time does, how Chainlink interacts with it. We're going to go through a full demo where you get to actually put fingers and keyboard, write a smart contract, or at least push one up to the chain that we will give you, interact with it, that then interacts with Space and Time. You'll be setting up an account. You'll get to see how a verified SQL sort of workflow looks like, and it's really quite amazing. Now, I will do my best, guys, to keep an eye on the chat, okay? But I've got it's like a bit like a cockpit here, right? I've got all these things going on here. So if I miss a message in the chat, don't take it personally. Try and ask it again. There are folks in the audience that may be able to help out. If any of you know the answer, please put the answer in the chat. Help each other out. And I'll do my best to keep up with the chat as well. And hopefully you'll all have a thoroughly enjoyable experience and learn a lot, upskill, and use that skill in the real world. Okay, so let's get started. Now you guys can all see my screen. I can see it on my screen that it's broadcasting to you guys, so hopefully that's okay. So welcome to the Build with Space and Time workshop today, Space and Time and Chainlink Functions. My name is Zubin Pratap. I'm the manager of DevRel Engineering here at Chainlink Labs. I'm an ex-Google SWE, and before that, I was a lawyer for a very long time, so I describe myself as a recovering corporate lawyer. That's how you can reach me if you want, using the X or the excuse me, I really need to update that logo, right? It's still got the old Twitter logo. Anyway, you guys know what I'm talking about. And LinkedIn, you can reach me on either of these places. So for today, we've got a pretty good agenda for you. Next 60 to 75 minutes or so, we're going to get you guys ready, right? Then we're going to hear about space and time directly from Scott. And then we're going to talk about, well, what we're building. I'll give you an overview of Chainlink Functions, the architecture, so that when we're actually hacking, when we're actually coding, you guys already have the mental model embedded in your head. So you know, all right, this is why this is the next step. This is why we're working with this kind of a contract. This is why we're doing this subscription or whatever it is that we're doing. All those words are familiar to you, and it's a little bit of a smoother experience for you. Sound good? Give me a thumbs up in the chat. Give me a yes in the chat. Put a number 1 in the chat. Whatever you like. Show me something that you guys are good to proceed to the next step. Hey, Onadan from Nigeria. All right. Man, you guys are slow in the chat today. Come on, warm up. Let's see some more chat action. I'm going to jump ahead because I want to make sure that you got, thank you, Darling Ark, and thank you, Travis. Awesome. Appreciate it. All right. So, like I said, for getting ready, the Git books at the bottom over there, at the bottom of your screen. And that's the best place to start. But you know, all the instructions for how you start are actually in the Git book. So for example, this is the Git book that I'm sharing with you on the screen now. If you go to prereqs and startup, all the steps are here, right? I would strongly encourage that you guys do this if you can over the next few minutes, because I will be jumping into sort of the latter half of this section just to give you a run through, but I won't be walking through all the faucet stuff. Now, for those of you who want the faucet, for the Avalanche, you can use this one. Let me show it. Now, it's a bit of a ticker, so you can use the workshop-faucet.versal app faucets Fuji. Now, that ticker, I'm going to leave that on there for a while along with the Git book. There is a temporary password that we made available because it is gated, it is passworded, so that we don't get drained all the time. And the password's also there. So I'm going to leave that running for a while so you guys can go through the setup steps. And let me go back to the presentation now. All right. So in terms of setup, you know, if you can sign in and register, do it. That's great. All the steps are there in the prerequisites. That's the faucet that we already talked about. That's the Git book that we've already put up for you along with the faucet on the screen. And then the actual GitHub with the code repo is available in the GitHub and in the Git book anyway. You'll see it there. But I'll put that up. I'll put that banner up on the screen in a little while when we get there. Okay, cool. Now, before we go into more details in the coding stuff, let's hear from Scott. Is Scott here at the moment or not yet? Or is he running a bit late so we can?
I'm talking. All right.
There you go. There you are, Scott. Perfect.
Hey guys, I'm right here, just tuning in, excited. I'm actually more excited about this than anybody because I want to see exactly what a contract looks like that calls space and time. I'll be coming on. You'll be hearing from me. I'll be giving a quick presentation on kind of the space and time architecture, how it works. But in the meantime, I'm excited to see where this goes.
Awesome. Scott, I just wanted to check, did you have a presentation that you wanted to make right now, or did you want me to
Let's get right to it? Okay.
Okay.
Everyone, my apologies. Just getting started right now. So what we're going to do is we're going to walk you through 3 things. 1 is how to access space and time docs. 2, what space and time is and why we're integrated with Chainlink. And then 3, and most importantly, this demo that's about to occur today. I was up all night last night coding, fixing a bug. I have not slept. I'm tuning in on my favorite friends from Florida. I just flew in from California to meet with some of our most battle-hardened engineers, getting space and time. There's a few critical bugs that we just fixed last night, live on chain, deployed. Space and time itself just went live with mainnet, and we have been up all night keeping that chain afloat. And we're so excited to be here. And what I wanted to start with is the space and time docs. What we did is we split out our docs between the actual space and time blockchain, which I'll explain in just a moment, as well as Make Infinite Labs, which is an American engineering firm that contributes software to space and time. They've even helped Chainlink with a few projects. And Make Infinite is a managed database of index data from major chains like Bitcoin, Ethereum, Polygon, etc. On the space and time side, the space and time docs, you can learn about the space and time chain. Space and time chain is the first, I would say, decentralized SQL query engine. You all have heard of Filecoin, you all have heard of Arweave, you all have heard of the graph. Functionally decentralized databases. On the other hand, you have Chainlink, the most robust, most battle hardened, and I would definitely argue most secure Oracle, decentralized Oracle, delivering data as a kind of a conduit to get data from other chains to smart contracts or even from their own chain. And what we realized looking at Chainlink, this powerful primitive that enabled a new generation of DeFi, what if smart contracts could access just a little more than just like price feeds, a little more history via SQL? Most of you on this call are very familiar with SQL. You, like me, had to write annoying SQL statements in undergrad. And when you were writing out select star, group by, where clause, a miserable language, but powerful. And the world's business runs on this language. I don't know if you lost me for just a second, and I apologize if you did. Calling in after a very long night of coding. What I was saying was SQL is uh, a miserable language to write, but it's very, very powerful. And the world runs on SQL. It's very, very efficient for processing data. So all Space and Time did was hyper focused for 3 years on research to build the first zero knowledge proof for SQL. Why? So that a global blockchain of validators can come to consensus securing data. And then when smart contracts need that data, for example, the history of swaps in a Uniswap pool, our ZK prover can answer the question with SQL, return a SQL query result, as well as build a ZK proof that we haven't lied about that answer, and functionally build the first decentralized SQL query engine, the first, ZK proven SQL. And we can deliver that to the chain through Chainlink. Chainlink can be the conduit that delivers these query results plus proofs back to smart contracts to be verified. So functionally, all you do on space and time chain is create tables and insert data. But if you're a developer and want to get started quickly, you can get started even faster at docs.makeinfinite.com. That's our easy get started developer docs, the Web 2 API driven experience for just accessing data fast with a scalable Spark engine. We call it a managed database that has a ton of data from Bitcoin, Ethereum, ZK Sync, Base, you name it. And these queries scale out on Azure. This is not meant to be the fastest database. It's meant to be the biggest. We're processing 100 terabytes in this environment just for you. And so you can run sizable, scalable queries that run for 4 or 5 minutes if you absolutely have to do analytic work on the blockchain. This is not a little API to get the latest block. There are plenty of better services for that. What we built you guys is a scalable query engine for doing real work, real research, real analytics with index data. We built you an awesome user experience at app.spaceandtime.ai. At app.spaceandtime.ai is the most self-service, easy to use way to explore this data and actually run Spark queries that actually access that data. Perfect. You can log in, get a free trial, run, 30, 40 Spark queries, and heck, give me an email. I'll give you 100 more, I'm sure. No problem at all. And today we're going to talk about using Chainlink to get some of this verifiably indexed data back to a smart contract. Lastly, what I want to talk about is why we use Chainlink and why we integrate. Developers are familiar with Chainlink and trust Chainlink. Chainlink is not just good technology, it's built a brand around being reliable, being elastic during times of high volume on chain, What no one really understands is the level of effort and engineering that went into years, I believe 5, 6 years of heavy engineering as a team to get past the struggles of being elastic during crazy activity on chain. Furthermore, it's a great SDK for developers who are writing smart contracts to get started calling Chainlink services and getting comfortable calling Chainlink services and just using Chainlink as a front to a wealth of other services that can be accessed via functions, automations, etc. And all of you are starting to learn about Chainlink functions and all these tools. These tools offer an easy way to interface with other powerful primitives that can expand the set of data that your smart contracts can access. One of those sets is space and time. I apologize, I don't have a more polished presentation for you today. I did, it's on a laptop and it's in Los Angeles. But I appreciate y'all having me here, and I'm here to answer any questions you guys have. And I want to tell you, this is a fun environment to build in.
Thank you, Scott. Appreciate it. I gotta say, I don't really miss the days of startup all-nighters. You know, it's hard work. Congratulations, though. This is a huge push, huge achievement. Really well done. What you guys have built is actually quite extraordinary. You know, over the time, really well done. So I'm sure when you and your laptop reunite, you'll keep it shut for a little while and have a little bit of a break anyway. But in the meanwhile, good luck and great job to you and the team. Really outstanding job.
Well, I appreciate you being so helpful with the docs. It's a great place to start and a great just introduction to what we've built. Overall, it's the first ZK proven database. We cryptographically prove SQL, and Chainlink offers a way to get that on chain to your smart contract.
Perfect. All right. Well, with that said, I bet you guys have got really itchy fingers like I do to get actually cranking on the code. So thank you again, Scott. Have a great rest of your day. So guys, let's go on with the overview of everything that we're going to try and do today, right? So what are we building? Well, we are going to be building something with both Chainlink functions in particular, and I'll walk you through that interacts with space and times. You heard from Scott just now, right? It's verified index databases, interact with that, pull some data on chain relating to Bitcoin average fees. So that's an index database that among the many that space and time have available for us. We're just going to show you how to connect all the pieces together, get some data on chain. I'm going to leave you a little bit of a stretch assignment at the end for those of you who really want to learn and grow. It's not a huge one, but it will get you to really pay attention to the code because, you know, you can't always do this on a live thing where we go line by line. So there's a little bit of stretch assignment for you at the end. But basically, Chainlink using Chainlink functions is going to make a verified request to space and time through the Chainlink functions decentralized network that then computes that, brings that data back on chain, has also verified the actual computation of the data back onto the chain. And so you have the actual data in the tables that's verified, and we have the actual result back on chain in your contract that is also verified. And that's just a demonstration of how you can verify every step of the process, right? Now, very quickly, let me walk you guys through what is Chainlink functions. I will say that not everyone's going to be totally familiar with Chainlink. So let me give you a quick introduction to Chainlink itself, why it exists, why we believe it's a really important piece of the puzzle when working with decentralized technology. And then I'll go slightly deeper into Chainlink functions, and then we'll start coding. So blockchains have a problem, right? In that they're designed to be kind of hermetically sealed. They're designed to be cut off from the world because that's how you achieve consensus. Every node has to be cut off. They can only be connected to each other, and they have to agree on the data. And so they don't connect with real world data, right? Now you could have something in the middle, a single node or a single computer really that's connecting the off-chain and the on-chain world, but then you have known as the Oracle problem, which is that you have a single point of failure. It's no longer decentralized, and so on and so forth. Now, Chainlink solves the Oracle problem, right? It's basically connecting. It's a platform that connects the external world with the blockchain world, because the blockchain by design is not designed to connect to the external world because of the way it runs consensus. So Chainlink sits in the middle and connects the two worlds together, and does that without any loss of the cryptographic guarantees that we've all come to love and expect when it comes to the blockchain, right? So all the answers, all the responses have to go through the decentralized Oracle network that Chainlink has built. That's the technology that Chainlink has built, and node operators and others. It's decentralized. They run all these nodes, and you can get consensus on the data from off-chain across all these nodes using the off-chain reporting, the OCR2 consensus mechanism, right? That's how Chainlink nodes sort of mimic what happens on a blockchain. It attains consensus and then posts that result back on chain. Now, if you guys want to know more, there's docs.chain.link. Very easy to remember, docs.chain.link, where you'll see all of these. And you'll see we have several services there. Not all of them are actually listed here at the moment, but these are the big ones, right? And today we're going to be using Chainlink Functions. We're going to be using that one, right? So Chainlink Functions, folks, is how you get decentralized and verifiable, cryptographically verifiable consensus on the result of computation returned by your custom code, and where your custom code can connect to any data source on Earth. Now, that's quite a lot of concepts. So let's break it down, right? First and foremost, you write some custom code, right? In this case, we're going to do JavaScript. You provide that to the Chainlink decentralized Oracle network and say, hey, in this code, I've got code that pulls data or even sends data to any API. In this example today, we're going to do to the SXT, to the space and time API, right? So your custom JavaScript, you write it any way you want. You can inject secrets, you can inject dynamic arguments and variables, and then you run it on the decentralized Oracle network on Chainlink Functions, and it connects to the external data source, pulls in the data. Then your code also pushes it back onto the chain, onto the contract that you've written. So you have to write a client contract. For those of you who are familiar with the client server architecture, you write a functions consumer or a functions client contract, which sends the request to the Oracle network, which then handles the external API calls, and then also receives via callback the fulfilled answer, the response to the computation, which gets posted to your contract, to your smart contract, your consumer contract, after being verified by the Chainlink Oracle network, right? So it's decentralized and verifiable consensus on the result returned by your code, which is connected to a data source. Okay, so that's quite a lot of things to think about. Now, obviously, as we walk through, we're going to be we're going to be going through code. I'm going to be sharing my screen and all the rest of that. But like I said, it would be really helpful if you guys have, let me change screen. If you guys have gone to here, prerequisites and setup, right? And then if you've installed Foundry, all the instructions are here. If you've got some of the Avalanche Fuji AVAX from the faucet, and I'm going to put the faucet back up on screen so you guys can see it, and I'm going to put the Git book back up on the screen so you guys can see that as well. Remember, the faucet does have this little temporary password that you need to put on, which is there at the bottom on the ticker. Okay, and then we can walk through also getting you the space and time stuff. API keys, as Scott talked about. We can do that now. Or if you are following along, you can do it ahead of me as well, but I'll quickly walk you through that. Now, I've got my space and time API key, so I'm not going to create a new account and all that, but I'll walk you through how you do it. Okay, so what do you need to do? This is what Functions does, right? You need to only do this bit. Let me turn on the laser pointer. You only need to do this bit on the left. You do not need to do all this stuff here. Okay, that's the benefit of Functions, but it's hard to know, well, what all needs to happen when you're letting your consumer smart contract, which is this thing, interact with a decentralized Oracle network. There's an on-chain component, there's an off-chain component, there's a decentralized component, there's an API, round trip component. You don't need to worry about most of that. What you need to do is you create a little Chainlink subscription, fund it with some link. I'll walk you through all of that. You deploy a consumer smart contract. You register that consumer smart contract with your Chainlink subscription to say, hey, this consumer contract can actually ask for computations. I've authorized it to ask for computations using my subscription account. Otherwise, anyone can use anyone's subscription account. That's not secure. So you authorize your consumer contract. Then you send the request to your consumer contract, which sends it over to the Chainlink Functions on-chain contracts, right? Invoking that. This little request will contain all the data your request needs, right? Including the JavaScript source code that we're going to send to the Functions network, the Oracle network. Then Chainlink Functions will create the computation, do the rounds, It'll go and get the API, in this case, which is space and time. It'll go and hit that with a SQL query, get the verified SQL query results back, achieve consensus on that, come back on chain, get posted to your consumer contract, and we can look into it. Now, there is a way to add automation, Chainlink automation, which is basically like a way to automate interacting with smart contracts, including your smart contracts. You can add that piece. We won't do that today, but you can add that if you like, and you can automate this entire process where you can keep adding a new SQL query and then run Chainlink automation at a regular interval. You can get it to go and execute that SQL query via space and time and bring it back, right? Cool. Okay. So again, just to be really clear, you do not need to worry about all of this stuff on the right here, right? This is what Chainlink will do for you. All you need to do is set this stuff up and off you go. Off you go to the races, as I say. Okay, so you guys ready to hack? Yeah? Ready to get our hands dirty with some code? Like I said, we do want to go, again, the Git book's down at the bottom of your screen. We do want to go there and we want to start getting some stuff together. So I'm going to assume you've installed Foundry. I'm going to assume you've got Node and NPM or Yarn or PNPM, whatever it is that you want to use. Please also use the faucet that we've given you on the screen, along with the temporary password to get some Avalanche tokens. And if you want some link, you can get it there too. You can get the space and time API key like this. Now, what I'll do is I'll launch actually, I've got my studio open here, don't I? When Scott was presenting. So I'm going to sign in with my details. You guys aren't going to be able to see this, so that's okay. And I'm going to just put my autofill. There we go. And I'm going to log in. Okay, so now that I've logged in, so if you guys go here, you won't see the login, but you will see the, okay, actually, let me log out and then show you again. So if you want to sign in, you can go to the register button if you haven't already, right on the bottom right, and then create a username and a password. The email is optional. You can connect your wallet optionally if you want. I'm just going to log in back again. And once you log in, you can go to my account, and then you can go to developers and APIs, and you can go to API authentication. This is way down the bottom left. Again, all of this is here, right? All of this is given with full pictures. You can see the whole thing here. Developers and APIs, you go to API authentication and you create an API key, API key for Chainlink Functions. You can just add it, and then that's the name that you can give it. I've given mine as a few other names, and then there we go. And then you can copy yours. Now, obviously, this is not the whole thing, and I'll be deleting mine afterwards. So that's even if you pick mine up, it's not going to make a huge difference. You can just create your own for free anywhere. So that's what we do to get the space and time API key. Now, keep that window open. Don't shut it, because you will need it during the workshop unless you've got another mechanism. You maybe have a notepad open or something, but keep that window open because you'll need the space and time API key in a moment, right? You'll need it when we're actually coding. All right, now let me also get some other things ready, and then we're good to go. All right, cool. Sorry, that should have been nice and pretty and full screen for you. So once again, workshop faucet also on the screen, Gitbook also on the screen, and the actual GitHub code is in your Gitbook, but it's also here if you want to do it, and I can put that up later on if you guys want. Okay, so next steps. Actually, no, we're still at the let's hack phase. And let me make sure that you guys have come up to speed. So we've done this Chainlink, sorry, I beg your pardon. We've done the space and time API key step. Now we need to create a function subscription, right? So like I said, when you're using decentralized services, as you guys well know by now, when you're using decentralized services, you need to pay a token of some sort to fund those computations involved in that, right? Because it's decentralized. And so Chainlink Functions is funded with Link, which is the Chainlink utility token that funds the computations that the Chainlink decentralized Oracle network does. So to do that, you want to open this Functions web app, right? Which is, actually, let me zoom in a bit, guys. It's a bit small for you, isn't it? There you go. That may be a little bit better. All right. So the Functions web app is basically a front end. I should have actually pressed Command and done that, because now I have lost the Gitbook. Right. Okay. I'm going to open the Gitbook here again. and make sure that you guys can see this properly. So I actually had the functions web app open, which is why when I clicked on it, my deduplicator got rid of it. Okay, so if you go to functions.chain.link, and then you go, you choose Fuji in the upper right, You choose the Fuji network. Oh, because I'm connected to it, it's not going to show. But you will see from the link, it'll say /Fuji, right? And then what you got to do is you got to create a subscription. So you click create a subscription. This is kind of, that's what you do. Subscription name is just for the demo, May 2022. You agree to all this, and that's my wallet address, which I've connected up the top here anyway. So, it'll fill that up for you, and then you create a subscription. So it's going to ask you to confirm and approve. So you confirm and approve because you're signing things to the smart contract to create the subscription, which is on chain. You receive a confirmation. Here you go with confirm. Now you go back to sign message. And that's kind of what we just did. And now it's going to wait. So the transaction's done, and it's going to wait till the subscription's created, which is, because on the blockchain will take a few seconds. Wonderful. The UI is, I didn't do anything. I just said the subscription's created. Now you can add funds to it directly, which I recommend you do. So I'm going to do add funds. And, if you need a link for testing, you can go there. What I'd recommend is using the first faucet that I sent you guys. Again, the tickers in the bottom. Use that faucet, use the password. When you're going to the faucet, there is a slight weird bug on this at the moment, which I need to fix. But if you click on that, it may not switch. So click kind of to the right. And the best way to know that it's gone there is you'll see faucet/Fuji will show up on the URL, right? But I mean, I'm already there. So it's going to say faucet/Fuji. That's also the link I've given you in the URL. So you should be fine. Put your testnet account address here, and then you can choose link and Avalanche. And then send the request, and you'll get the funds in your wallet, right? So I'm just going to say I'm going to add, let's say, 3 link, which will come from my wallet to the subscription. And so you add funds, and I'm going to confirm that. And so it's sending 3 link to my subscription from my wallet because I already had preloaded my wallet with the link. And then once it's done, my subscription will now have 3 link to spend, which we'll need much less than that for this demo. Now, adding consumer is saying, hey, do you want to add a smart contract that is authorized to use this subscription? Now, we haven't deployed ours yet. So I'm just going to say no. I'm just going to click out outside the modal and then I'll do later. And we're done, right? And now that's my subscription. I've given it a name, demo May 2022. Now the subscription ID that I've got here is unique to me, obviously. I mean, anyone can access this. It's public, but you're not going to be able to do anything because it's associated with my wallet. But 15512 is the subscription ID I'm going to need, right? When we go through the demo. So let's see. We've created the function subscription. We've done all of that. Again, we've got screenshots here that are helpful. That'll give you everything you need. Keep the URL, keep the functions ID, subscription ID, and your space and time API key. Like I said, keep it handy. Keep all these pages open as well in tabs. And now let's code. Okay. So the first thing we've got to do, that's the GitHub repo, right? The first thing we've got to do is actually, I need to make sure you guys can see my screen. Can you guys see that? Can you guys see my terminal? Someone give me a yes or a 1 in the chat, please. And let me know if you need me to go a bit bigger because I'm going to go git clone that, right? It looks fairly visible for me. And hopefully you guys can see that. I'll just give you guys a moment. Cool. Awesome. Thank you, Totaling Arc. I appreciate it. All right. So I'm going to git clone that. What just happened? Git clone. Oh, I see. Because I had the whole command was copied. I'm so used to copying from Git. So I'm just going to do git clone that way. Right. And I'm going to cd into functions SXT workshop. Perfect. Thank you, guys. Thank you. Now I'm in functions SXT workshop, and I'm going to do code from in here. So that should open up my VS Code. Hopefully you guys should see that. Don't worry about the errors. That's just stuff that happens in mine. And I've zoomed in a bit here for you. And I want to make sure that I've toggled screencast mode. Okay, so you guys can see the keyboard shortcuts I'm using as well. Perfect. We're good to go. We're good to go. All right, so from here on, we've got the repo on our computer. All we got to do is follow the steps, right? So we've done the CD functions. That's what we just did. Now we have to, assuming you already have Foundry and Forge installed, Forge install will just install the packages. And for those of you familiar with Foundry, it uses symlinks. So these will be empty right now. But when we do Forge install, it'll populate that. Now this could take a little while. Right, this could take a little while because Forge basically does, there's a lot of stuff that it needs to pull in, all the dependencies, and then the next step will be npm install. I love the balloon emoji. I'm not quite sure whether you're saying I'm full of hot air or this is a celebration, but I'm going to take it as a celebration. Tolling arc. So okay, so we've done Forge install. It's going to keep doing it. It's almost done, and you'll see that now things in here have started to populate. Previously that was empty, now it's just full of stuff, right? So that's what Forge install does. There we go. We've got everything here. I'm just going to do clear. What's the next step? It's the npm install, isn't it? Yes, it is. So I'm going to do an npm install here. Now I have some weird npm issues on my laptop, so you probably won't get some of the errors that I will, but don't worry about that too much because I have a M1 chip. Long story. Let's not go down that rabbit hole, right? But I'm going to do the npm install, and we should have that running well now. So what is npm install doing? It's installing the non-Foundry related dependencies for the JavaScript part of this repo into node modules, right? That's what's happening here. Now, while we're doing this, what I recommend you guys do is if you look at this end.example, I'm just going to, because this is still downloading, I'm just going to close the terminal. What I want you guys to do is I want you to go to .end.example and just copy the whole thing, right? Then here, you just right click and you do new file in your project root and just write .env, right? Now this will be git ignored. So this is the stuff that you won't be pushing into GitHub accidentally. But we've provided some of the stuff here, like we're using a public RPC URL. Now, environment variables are things that you have to inject into your code. They're the secrets that you don't want the world to see. So in theory, I shouldn't be screen sharing this, right? But I trust you guys, but I don't trust you guys necessarily. No disrespect, but this will probably end up on YouTube or something, and I don't want my private key out there. So I'm going to do just a variable expansion into my private key there, and hopefully that should work. If I get alerts, then I may have to paste my private key into it properly, but that should work. And so you have your SXT API key, right? So I would recommend that you guys do that now, that you absolutely paste your SXT key in here. Now I'm going to paste mine in here, and then I'm going to delete it after that. So even if someone does kind of mess with it, I'm okay. Sorry, I had the wrong screen. There you go. So that's the SXT key. My function subscription ID. Let's see, what was it? This one was 15512. So I'm going to put that in here before the octothorpe, the hashtag, yeah, because that's the commenting thing. So I'm going to put it in there. 15512. All the other stuff this is optional, don't worry about it for today, but the other stuff we can put in later on. Now let's check our npm install. Cool, we've got, don't worry about the transitive dependency vulnerabilities and stuff. That's fine. Okay, so I've cleared the console, and now let's go back to our steps. So we've done the npm install. I just talked about it while it was installing. I talked about the environment variables. So, you can do copy, or you can do it the way I did, which is manually copy and paste it. And you want to sort of replace these three values, which we did. Now, what we want to do is anytime we change our .env file, we want to run the command source space .env, right? And the reason for that is we're basically loading these environment variables into the session, because otherwise when we make changes, it may not be there in the terminal session at the moment. So for example, if I now do echo function subscription ID. Subscription. Oh, I miss an S. Right. If I do that, you'll see my subscription ID from here. Right now, this is not really a secret. It doesn't really need to be kept secret. Like I said, you need your private key to be able to interact with your subscription. But we put it here just so that it's dynamic configuration. Okay, cool. Yeah, thanks, Steve. This is just the beginning. I'm glad you think it's cool. There's a lot of fun stuff that you guys can learn about software engineering generally, about projects generally. Like it's a good project, I think. Okay, so we've done source end, so now we've loaded it and we can test it by checking that something that we put here is going to show up. When we do echo and $ and that thing. Now, the next step is we need to upload our secret. Now, what is our secret here? Now, this is where we start getting a little bit into the depth of the project, right? Now, the secret that we are uploading is the SXT API key. Why do we need it? Now, I'm going to move around a little bit, guys, but just try and follow as best you can, right? Remember how we talked about sending our custom JavaScript to our smart contract and then onwards to the decentralized Oracle network so that it could execute it, call the SXT API, bring back the verified SQL response, etc. Right? Now that custom JavaScript is already provided you under function source being the source code that we want to send out, space and time Bitcoin request. Right? Now let me just close my terminal for a moment. You will see that right up here, we have a secrets.sxt API key, right? That secrets needs to be passed into the runtime, into this code dynamically. But because if we hard code it here, we could accidentally put it to GitHub or anybody who's snooping around could see it. So we need to make sure that these secrets are dynamically injected into the runtime at runtime by the Chainlink decentralized Oracle network. This is a security feature, right? So to do that, we need to do something called uploading the secrets. Now, there are two ways. You can look at it and read more about it here in the Git book, but there are two ways. You send the secrets in encrypted format, right? You encrypt the secrets locally, and then you send it to the decentralized Oracle network. So nobody else who doesn't have the private key can do it. And the decentralized Oracle network uses something called it's called threshold encryption, which basically is very advanced security. You can read about it. Why did it do that? Interesting. It reloaded the page. And so you can go there, go to the links that we provided you and read more about it, about how threshold encryption works. But the long and short of it is your secrets are safe, right? You encrypt it so no one else who's snooping on it, who's looking at the bytes, can actually read the data. It goes to the decentralized Oracle network. It has an expiry time on it, which we'll set, which is set in the script. And so we upload these secrets to the decentralized Oracle network. The decentralized Oracle network will dynamically inject it into this code, JavaScript code that's being executed at runtime. It'll be available as the SXT API key on the secrets object, so secrets.sxt API key. And then this gets used in the actual post request to space and time, right? Because we need to give them the space and time API key. So this .end value, this SXT value, gets in, we upload it to the Dawn securely in an encrypted format, and then the Dawn injects it into our script. So to do the upload, we've given you a script here. If you go to script/upload secrets, you will see the script here, right? So let's quickly walk through this. It has all the configuration because we're using the Avalanche Fuji network. It has all the Chainlink Functions configuration. We need to interact with the Chainlink Functions router. We need to give it a decentralized Oracle network ID, etc. All this stuff is available here on this. I put the URL here. Yeah. And then these are the gateways to which we send the secrets in encrypted form. Minutes until expiration is how long the secrets will be kept on the decentralized Oracle network. It's one day at the moment. So for security, you can do as little as 5 minutes. Okay, if you want to keep refreshing your secrets, the upload secret script actually just connects to your wallet, your signer. That's why you need the private key, which we've set. It uses something called Functions Toolkit, which is a package that a colleague and I have written that helps you use JavaScript to interact with all of this Chainlink function stuff. So it creates a secrets manager, initializes it, it encrypts those secrets, right? It's secrets manager.encrypt secrets. So the secret manager helps you encrypt the secrets, and then it uploads the secrets to the Dawn. You give it all the configuration, you give it the gateway URLs, etc. I know this is quite a lot. So when you read the code, it'll make sense, and then it'll tell you whether or not it'll be successful. So if we are successful in uploading the secrets to the Dawn, it'll say secrets uploads successfully. That is what we can expect to see. So the next step here is to run that node script. So I'm going to just copy it from the Git book. You know what? I'm just going to move this here because I'm not using that terminal as much. So I'm just going to use the integrated terminal. You guys can see the integrated terminal at the bottom. I'm going to clear the screen to make more space, and I'm going to run node script upload secrets, right? So interesting. So it's got this value. So let me see what I can do about that, because it's not actually getting my let me just sort this out in a sec. I think I know what's going on. So I may not have sourced it correctly. Let me see if that works. Source.env. Let me see if I load it properly, if it works. And I want to just check on another screen whether I've correctly set my environment variable or I accidentally changed it. Yep. Okay, cool. So I'm doing some stuff on another screen so that you guys don't see my private key. Okay, that's really what's happening. So source.env and then echo the private key. Yep, it's loading on my screen here, so it should load here in a moment. And I'm going to do node. Let's see what's happening. Interesting. All right, I'm just going to fix that in another way. Always the fun stuff with live coding is things don't work as you expect. So this is interesting that that's not loading, because it was definitely loading that way yesterday. Let me just triple check that. Yeah, that was definitely loading yesterday. So I'm going to try two more things, and then we are going to see what we can do. Maybe I need to share the other. Very interesting. That's definitely not what was happening yesterday. All right, I think I know how to solve this, so that's fine. I'm just going to update this here, remove this here. Sorry, you guys can't see this. I know this is very frustrating and annoying for you. I do apologize. Let me just sort this out for you so that we could go on. But the key point is, because I can't share my private key with you, we're in this situation where I need to try and use other techniques to get around it. And that sort of makes it harder for you guys to see what I'm doing. But the key point here is that you want to have your private key with the OX and stuff here, right? So I'm just going to create some more space, and I'm going to paste it in another screen, and then we should be okay. All right. Now I'm going to try and do. Yeah, I could do a disposable private key. That is totally true. I just didn't have the time to set that up this morning or last night. And I do try and sort of, have a specific demo private key. You're absolutely right. That's a much better way to do it. So let's see if that works. Yep, there you go. So that works. So what's just happened here, right? We are, and don't worry about this. Like I said, that's partly to do with my environment from switching from the old Mac to the new. So it's encrypting the secrets. That's my the first bit of my, and you'll see the first bit of your space and time API key, and we're uploading it to it. Now, what we need to do is, we see here that we've got a slot ID of 0, which we had set actually in the script, and the expiration time of 1440 minutes, which is 1 day. We do need to keep track of this, right? The version, the secrets version number. So I'm going to copy that secrets version number. I'm going to go to my .env, and I'm going to put it in here. In place of the 0, replace that here. All right. Now, as always, when we do that, we also want to do source.source env again. Cool. So now we've loaded that and we've stored that in our version. So we've done the upload secrets. Now the Dawn has our space and time API key, but in an encrypted format, right? We've done the source env, and we've already walked through what the script does, so we're good to go there. We've done that, and it explains what's happened here, what's gone to the Dawn. Now, next, what we want to do is is to deploy our functions consumer smart contract, which we've called the space and time numeric query contract, right? Now, we've given you a forward script here, and we'll do this in a moment, but let's quickly walk through what the contract looks like. Maybe I'll do it here. So this is the, close that thing. So this is the smart contract. Here you go. This is the smart contract. So what is the smart contract going to do? Well, it has to implement the functions client. And again, I'm walking you guys through this because it's no fun to just for me type commands and you guys not know what's going on. But also keep in mind there's a lot of stuff here, right? Like there's a lot of things that need to be kept in mind. So I'm doing my best to balance it. The good news is that all of this is already explained in the Git book. So even if you struggle to follow along right now, don't worry about it. It's very detailed in the Git book. And I'll give you resources on how to contact us later as well. Okay. So the SXT numeric query is our functions consumer contract. It needs to implement the functions client interface, which is imported here from the library. Yeah. And the only thing this functions client requires our contract, the SXT numeric inquiry, to do is it must implement something called a fulfill request. This is the only function that we absolutely need to implement if we inherit from functions client, okay? And that's the callback. This is where the Chainlink decentralized Oracle network sends back the response. You see this bytes, the response bytes, that's the result of that JavaScript computation, speaking to the space and time API and bringing that data back. So this is the only thing we must absolutely implement with this function signature. It must do that, right? That's why it says override, because it's overriding the abstract implementation in the inherited contract, which is functions client. That's a lot. That's a lot to keep in mind. So don't worry about it. But the key points here is, again, you're going to be seeing Avalanche related functions config here. These are some state variables. Yeah, subscription ID is what we did in the Chainlink Functions web app UI, and we then saved in a .env file. You can read about these things in the Chainlink documents if you want. The SQL query is what we will dynamically add in a little bit. Source is the JavaScript source code, is this stuff. SXT Bitcoin request JS. That's what the source state variable is going to be, but we haven't given it that yet. You will notice that it is set in the constructor at construction time. Okay, so at construction time, the script to deploy this contract will add to the constructor arguments the JavaScript source that we want to do. Now, there are other ways you can do it. Some people hard code it directly into this functions consumer contract, but then it adds to the storage size of it. Different styles. Some people just write scripts where anytime they need a specific type of JavaScript run, they will send all the arguments, they will send all the custom source, etc., into the contract at the time that they call the request. For example, they'd implement the request function here to include a source argument, right? People have done it all sorts of ways. Functions Toolkit will help you do it with any number of ways that you want because it's very flexible. Yeah. So we pass in the source and the subscription ID of our Chainlink Functions account at the time of constructing the contract, and it sets that variable, right? And then we will later call a script to request the numeric result, and we'll walk through that at that point in time. So at this point in time, all we want to do is we want to deploy this functions contract. So I'm going to copy the script from here, which is a forward script, and you'll see it takes the script, deploy this the numeric query contract to the RPC URL that we've set in the NV, and then broadcast, which means make state changes. So let me call that here. I'm going to clear my console so you guys can see a bit more. I've pasted in that script. And when we run that script, what we expect to see is an output like this eventually. Like this is a small part of the output, but you got to look for these kind of signs to know it's successful. So fingers crossed, let's see what happens. That's a good start. It compiled. Okay, beautiful. So the script ran successfully, and we have got, it's now pending, and here we go. This is the code that we thought, or this is the snippet that we wanted to see. Success, this is the contract address. I'm just going to copy that. And it tells you, okay, it's number, this is some information. This is all the way Foundry does things. That's the chain ID and all that. Great. Okay. So I'm going to switch over to my env file, and I'm going to put in the contract. Here we go. Contract address is here. So I'm going to put in place of 0x, I'm going to put my newly deployed contract there, right? Done. Save that. Open the terminal again. I'll clear it for you guys so you can see source and then load the environment variable. So source.env. Perfect. Cool. Now we've done with deploying the contract. What's next? We've examined the contract as well. So what's next? So we need to add this consumer contract to a Chainlink function subscription. I still have the contract address in my clipboard since I've just copied it and pasted it. So I'm going to switch over to functions Chainlink. This is the demo for today. It says it has no consumer contract added yet, right? So I'm going to add a consumer. I'm going to paste the contract address here. I'm going to double check that this is my contract address. So BB2 ending with AEC8, BB2 ending with AEC8, that's right. I'm going to add the consumer. It's going to basically update the state of the blockchain with my function subscription and say, hey, in this demo May 2022 subscription ID 15512, there is now one smart contract that is authorized to use that balance of 3 link to run decentralized functions executions of the JavaScript code that we're going to send to the smart contract in a moment, right? So let's wait till all this happens on the blockchain. All right, done. So it's added. All we got to do now is refresh this page, and you'll see that my contract has been added here as a consumer under my subscription ID. So far, so good. Now that we've added the subscription to the consumer thing, now we need to set the SQL query in the contract. So if you remember, close that out. In our smart contract, I said that there's a SQL query, and we need to set that. It stores the SQL query, but it's empty right now. But there is a function down here. Normally, I'd use keyboard shortcuts to find the function, but I don't want to confuse you guys too much in case for those of you who are still new to this. There's a set SQL query function at the bottom. We pass it the new query. It stores it against that storage variable, right? Which means we need a script to set the SQL query, and that's what this script does, right? So I'm going to do set SQL query. There we go. That's the script. You'll see it's inside the scripts folder, set SXT SQL query. So what's this going to do? Well, really, the short version is it's going to find, you see, it's going to load our contract address from the environment file, right? It's going to create an instance or a connection to that contract, if you like, using the Foundry world, right? That's our contract we just deployed. And it's going to call the set SQL query function. That is, it's going to call this function via this script, and it's going to set the new SXT query, which if I command and click on it, it shows us what the query is. That's the query. Now, what I'm going to do, guys, is I'm going to set the expectations of what we'd like to expect. I'm just going to copy that query without the quotation marks, okay? And then, remember how we had the space and time studio that we logged into? So if I go into the main studio, I can actually run this query right here, okay? We're selecting the average of the Bitcoin stats tables average fee rate for Bitcoin data. We're going to rename it as average fee. This is just SQL. I'm not going to actually break it down. And we're going to find stuff in the interval of the last 7 days, okay? Now, when I run this query, I'm going to get a result. Well, hopefully I'm going to get a result, right? And this is space and times verifiable SQL, right? And there you go. The average fee is 4.8650. This is good. We know the SQL query works. Now we're going to try and do this via a smart contract, because here I'm doing it via the UI, right? So we're going to run the set query script so that query string, that SQL query that we just saw, is going to be part of the smart contract stored as a storage variable. We've already examined the script, so let's go down to running this set query script now. The usual steps: open the terminal, paste that, and if everything goes well, we should see, well, what do we want to see? We should see something that confirms that it's been done, right? Hi, Andreas. If you want to create an MCP server, that's great. I'm working on an MCP server too. I'm a big fan of them. I actually don't know if there's a Swagger file for the API. That's a really great question. I don't think we have anyone from Space and Time's technical team here, but I'll ask the question. It's a good question whether they have a Swagger file for the API. Right, for the script. So what have we done here? We set the SQL on the smart contract, right? So it's successful. So that's good. We've done that. Let me close that out. What's the next step? The next step is now to actually invoke our smart contract, the one that we deployed, our functions consumer. We want to actually run a script that requests the SXT data. Now, if you look at the request SXT data script, and let me open it here, right? It's also in the scripts folder. What is it doing? It's basically saying, it's getting all the environment variables, the private key, the secrets version from functions, etc. It's getting a connection to our deployed smart contract here, SXT numeric query, and it's calling on the contract the request numeric result and passing in the slot ID and the secrets version, which is pulled out of an env file, as the input arguments. Why is it doing that? Well, because the SXT numeric query in that request function, request numeric result function, requires those two input arguments, right? What's this going to do? What's the request numeric result going to do? It's going to use the functions library that it's inherited from, right, to create a request object, to instantiate one, and then it's going to start adding data to that request object. It's first going to add the inline JavaScript, which is the source code. This SXT Bitcoin request thing is the first thing that's going to get added to it. Initialize request for inline JavaScript with the source. So it takes the request object here, adds the source code to it, right? Then it sets the arguments, right? The arguments being the actual SQL query, which we just set on the contract. It's reading that storage variable now, and it's setting it to arg0, the first element of the args slice, right? Sorry, that's Golang language, the args array. So it's setting the arguments to the request as well. Then it's adding the Dawn-hosted secrets. It's saying, well, you know what? We can't give you the secrets, but we can give you the slot ID and the version. Remember, the version was something we added to the env file right at the beginning, right? We said, here's the secrets version. So it's saying, here are the details. That's where the encrypted secrets are. That's where you can find the secrets injected into the source code when required, right? And then it'll tell you, well, the source is not set. If there are errors, that says some error handling, and off we go with the send request. So when we send this request, what are we actually doing? We're sending our query and our custom JavaScript to the Dawn for execution and telling the Dawn, hey, you're going to need some secrets when executing that. You're going to need the SXT API key. Pull that out from the Dawn hosted secrets, right? And so when we do that, when we run the script, we're going to expect that kind of a response. So let me just run the script here. Clear this, paste that. Here we go. So let's hope that the request fulfills correctly or executes correctly, and that Zubin hasn't made a mistake and then has to embarrass himself live on air with you guys while I try and debug that. I will say though, some of the best learning I've had and some of the best learning the audience members have had is when we've had to debug stuff live, because it's a classic thing with software engineering, right? Is what works on my machine may not work on yours. I mean, which is kind of why Docker's invented anyway. But what ends up happening is that environments may look quite different, and one command that works for you won't work for me. And sometimes Windows users will have a different set of challenges. So it's always fun to debug, I feel, because I genuinely feel that that's where the real learning is, which is why I put a little stretch assignment for you guys at the end, right? So don't worry when you guys see bugs. A bug is just a learning opportunity. It's something that's happening that you either knew about and didn't think about, or you didn't know about. Either way, you're going to learn and grow, right? So it's a great opportunity. Okay, so we have the success hash here. That's good. That means that the request was successful, which means we sent our SQL query and our custom JavaScript source code to our smart contract. NPM upgrades, man, don't even get me started on NPM upgrades. But let me just show you again which stage we're at, right? We're at the stage where we have sent this request data. There we go. See this request data thing here? That's the stage we've just done, right? So we made a request of our consumer. This is our contract. This is our SXT numeric query. And having done that, that's now sent this request and it's triggered off this process, okay? So that's going to take and I think I mentioned that here at the bottom. I said, this you may need to wait 1 to 2 minutes, right, for this to happen. So we'll wait for that, and then we can call the latest numeric result. Now, the calling of the latest numeric result will basically it's a for script that is going to call SXT numeric query the latest numeric result, which is one of the, here you go, the storage variables. How does that get set? Right now it's empty. So what's going to happen? So, well, once the Chainlink Functions decentralized Oracle network has pulled and validated the data from space and time's verified SQL databases, it's going to come back. Remember when I said it's going to come back into the fulfill request, right? We're going to get a response in this. The decentralized Oracle network is going to call our contract fulfill request. That's why we had to pay for the subscription, because there's gas costs involved in doing this. It's the transaction that changes the state of the chain, right? That's why we had to pay for it. And then it's going to set the latest numeric result here if there's no error, right? God, I really hope there's no error, because debugging, that's going to be a pain. But the point is, you can do this here. Latest numeric result, ABI decode. It is going to decode the result as a uint 256. And there's a small gotcha here, which is going to be part of your stretch assignment. But we can expect to see the numeric result that we saw earlier, something very similar to that from the UI. We should expect to see that on chain now. Okay. Totaling arc. No, this doesn't require the SXT token yet for this particular workshop use case. No. So to request the result, let's see if it's finished computing. I'm going to clear this, and then I'm going to call the latest numeric result storage variable on the smart contract. And yeah, there you go. Now the result is 4. Now, can anyone tell me why it's 4 and not 4.8650? For those of you familiar with Solidity, you'll know what it is. Ooh, drum roll. I wish I had a drum roll. I wish I had a dramatic music machine. I don't know, totaling arc, anybody else? Don't want to put anyone on the spot, but can anyone tell me why it's not 4.8650 and it's just been rounded down to 4 in our response? And I'm going to show you the code, because that may give you a little bit of a clue. So that's what gets fetched back, or that's what gets sent back into the smart contract. Let's look at our request, what it returns. Custom JavaScript returns encode uint 256, the integer average fee, right? So it's a uint 256 as bytes that's going to be received in the smart contract here on line 97. Why does it not have decimals? Totaling arc, I don't know what you mean by unit. So I'm just going to pretend like I don't know what that, I mean, I don't know. What do you mean by unit? So why, the clue is here. The clue is in uint 256. Ooh, dramatic pregnant pause. What's going to happen? Misspelled. All right. Okay. So it's a uint. You meant to say, yeah. Okay. So you're warmer now. Okay. That's funny. Unit. You meant uint. Okay. Yes. It's a uint type. It's an unsigned integer type. It's not a floating point type. Solidity doesn't handle floating point numbers, which means for you to get 4.8650, yeah, you've got to do a little bit of a computation here, right? So you've got to figure out, and this is your stretch assignment, how would you return 48650 as the whole thing from the result, and then set it in your smart contract as a uint, and then work with the decimal places, right? Now, if I were you, I would continue to see if I can work with it as an integer, or an integer, and return maybe a decimal type. If you look at the functions documentation, there is a guide on how you can return two values from your custom JavaScript, right? But if you keep it as integers, then you're not having to do manipulation. But if you return it as a string, now you have to convert that string into a number if you need to do computation on it. But if you're just consuming on a front end, then you can display it as a string, no problem. So that's a stretch assignment. How would you guys want to do it so that you include data about either the number of decimals, or you include it as a decimal, but it's actually a string and not a number, right? That's the stretch assignment. But the good news is our decentralized functions Oracle network contacted the space and time API, which is verifiable SQL, got the data from them, and posted that back on chain. And every step of that has been verifiable, right? Every step of that has been verifiable. So that I would consider to be a very successful run of how you use space and time and Chainlink functions together to get a result. Now, here's your stretch exercise, right? Here's your stretch exercise. I've even given you a link to the to the documentation that has it. Oh, I know homework. Ugh, doodling. I know homework. Ugh, right? But hey, that's how you learn. That's how you get your hands dirty. That's how you get better. That's how you get the muscle memory in these fingers. So that's part of the joy of coding, right? Is there's an endless learning. Cool. All right, so that's pretty much the end of where we are with that session. So you've got, here's a little congratulations for you, and there's helpful resources at the end of the Git book. But let's get back to the presentation very quickly as well, and we'll talk about your next steps. So for the next steps, what I'd encourage you guys to do is sign up for the Chainlink Hackathon, right? So that's hack.chain.link. You can learn more here, hack.chain.link. It's going to be starting very soon. This, as you can see, I mean, it's all on the slide, right? 200K plus in prizes. We've got a ton of really great tracks, and prizes based on the tracks as well. Got some big name sponsors, as you can see there, and we got really great partners that you can sort of learn about as well. So I strongly encourage you guys to sign up on all that until AI takes our jobs. I don't know. I'm not sure it will. I think AI will just help us do certain jobs better and make us grow a bunch of new skills. Like I'm really excited about the AI, but maybe I'm just needlessly optimistic. I don't know. I'm pretty. I just, as a student of history, I feel AI is going to be helping us. I remember when I started my career as a lawyer almost 25 years ago. I know I'm an old guy. We had people like a specialist pool of typing people, right? We'd call them the stenos and the typist pool. We don't have that anymore, right? But people get new skills and they get other jobs, and and things grow. That's how society grows, right? So I'm very optimistic about the AI thing. Anyway, back to the Chromium Hackathon. You guys should absolutely sign up for it. We have thousands of people who usually do this hackathon. It's a lot of fun. And what's really important is that you grow a lot as a developer, but you also make a lot of really good relationships. And tons of people have got jobs and careers out of these hackathons that we do, right? So it's really wonderful. Now, here's how you get resourceful. Sorry, can't help the dad jokes. These are the resources that you can access. They're also at the end of the Git book if you want. I also recommend that you guys look at Updraft and get the free Chainlink certification that we've just relaunched with the help of the Cyphren guys. For those of you who know Cyphren, which Patrick Collins, who is ex-Chainlink, sort of and his partners have built this company. We have a free Chainlink fundamentals certification there as well. Strongly encourage you to go and look at it. We relaunched it with them just a couple of days ago. And this is free. You get you get the certification at the end of it that you can show off to the world. We've had, I think, over 1,000 people in the first 24 hours go for it already. So absolutely get in there. You'll learn a bunch of stuff about other Chainlink things. If you need more help and support, that's our Chainlink Discord. And if you want, sample use cases and repos, then you can see all the other ways to use Chainlink functions here. And functions toolkit, which we've used in our demo, is also there. Yeah, tons of resources. Take a photograph of this page, take a screenshot of this page, go and check it out. Definitely do the hackathon. I reckon you guys will love it. And you'll build really amazing relationships. We have some great stories of people who've done really well, won prizes, got careers, got jobs, got new opportunities, relocated, just been noticed by other big, sort of blockchain protocols and stuff. Like, it's a great place to get noticed, and definitely take a screenshot of this stuff. And with that, thank you very much. Thank you for your time. Thank you for your patience. Thank you for your kindness while I'm not throwing rotten cabbages at me while I was trying to figure out how best to use my private key. Totaling Arc is right. Using a disposable private key is one way. I just ran out of time because I didn't want to have to add all the funds and do all of that. So, I do apologize for that, but you got to see an empty screen for 5 minutes. Like, what's more fun than that, right? While I did my stuff. Surely you enjoyed that. Anyway, thanks guys. Thanks very much for attending. Thank you for your interest. Do go and check out the space and time stuff. As you can see, the documents for that are here. Docs.makeinfinite.com, right? Docs.makeinfinite.com. Go and check it out. You can start there. And the studio is app.spaceandtime.ai. Okay, go check it out. play with stuff, build amazing things. Come show us in the hackathon, and we will see you next time. Take care, you guys. Bye.